Well, in this video, we will be learning how to find the integral of functions of the following form, and that form is written as the integrand here on the screen. Sine to the power of a of x times cosine to the power b of x dx. There are several different cases that we need to consider when our functions are in the following form. For the sake of this video, we will be discussing the first case, and that is where either a, and I'll write this on the screen, either a or b, and actually and or b, so I'll write a and or b are odd numbers. So b equals odd. Now this is the easiest case because when either a or b or both of them are odd, we're able to take advantage of the fact that these functions of sine and cosine are related in many ways through the trigonometric identities. And the one that we're going to be using for the sake of this integral is going to be the following identity, and it's probably the most common. Sine squared of x plus cosine squared of x is equal to 1. Now the idea here is that when a or b are odd, or both of them, we're able to rewrite this integral in a very convenient way of using a u substitution, and then we will eventually be able to, after that u substitution, solve the integral, which will be a polynomial, and then we'll be able to plug in our u, and it will be a much easier integral to solve directly than just looking at the trigonometric functions that we have right now. So let's hop in, let's look at an example. I believe that will explain the technique the best, rather than me writing the general technique or the form. I think that solving an example will be better. So we'll start off with example 1 here, and it'll be a rather simple one. It'll be the integral of sine cubed of x times cosine of x dx. Now the first thing that we realize here is that our a is equal to 3, and that's if we are using this form right here, and our b is equal to 1. Now in this case, both 3 and both 1 are odd, so the following technique is going to work. Now what we're going to want to do is in order to apply this technique, we are going to need at least one of these functions, sine of x or cosine of x, to be to an odd power greater than 2. So we're going to choose sine cubed of x here because 3 is greater than 2, as opposed to cosine of x. In the case that you have the integral of just sine of x times cosine of x, where both a and b are equal to 1, then you would immediately be able to apply the u substitution, which we've covered in earlier topics. So now that we've decided that yes, indeed, our integral here is of the form where at least one of the powers is odd, what we're going to do is we're going to take this sine cubed of x, and we're going to use this identity up here where we know that sine squared of x is equal to, and we're going to subtract a cosine squared of x on both sides, is equal to 1 minus cosine squared of x. Now if we rewrite our sine cubed of x, what we'll have here is this is a sine of x times a sine squared of x. If we multiply them together, we'll add the exponents, and it'll be 2 plus 1 is 3. And then if we rewrite this using our identity, we'll have sine of x times 1 minus cosine squared of x. Now, what we can do is we can rewrite our entire integral here, and we'll have a sine of x, and this will be times 1 minus cosine squared of x, and then times cosine of x dx. Now, what we do now is we use our u substitution to our benefit. So we're going to do u equals cosine of x. And so then if du is equal to here minus sine of x dx. And notice that we're doing a u substitution of cosine because the cosine is right here, not necessarily because the cosine is right here. Whatever we transformed, or rather converted, the sine of x into, using our trigonometric identity, that is the trigonometric function that we want to use for our u substitution. So now that we have our du and our dx and our u, we can rewrite this function, or this integral rather. So notice here, and I'll actually move the negative sign to this side, so we have a negative du is equal to sine of x dx. Notice that we have and I'll use a different color here, I use blue. We have sine of x dx right here, and we have a sine of x dx right here. So now, in place of that, what we can do is we'll first write our integral, and then we'll have a 1 minus a u squared, and this is coming from the parentheses in the first integral, times a u, because we have the cosine of x at the end. And now our sine of x dx is equal to a negative du. Now we can rewrite this integral. And what we get now is we get, well, we can distribute this negative to the first parentheses, and we'll get a u squared minus 1 times u du. And this is equal to, well, we can distribute that again, and we get u cubed minus u du. And basically what we've done here is we've started with a rather complicated trigonometric integral, and we've converted it into a polynomial. And so now we can apply the power rule, and we have 1/4 u to the 4th minus 1/2 u squared plus our constant of integration. And now if we plug in our u here, which we determined was cosine of x, then what we will get is we'll get 1/4 cosine to the 4th of x minus 1/2 cosine squared of x plus c. And that indeed is the integral here. Now, so what did we do? We realized that if we have a trigonometric function, sine of x or cosine of x, and one of those is to an odd power, what we're able to do is we're able to take advantage of this identity here. And we're able to strip away all of the sine of x's and convert them into the form 1 minus cosine of x, or cosine squared of x rather. And what we're left with outside of the parentheses is always 1 sine of x, which we have right here. And then by using the u substitution, u equals cosine of x, which we'll always have because we already converted it into 1 minus cosine squared of x, as our du, we will always end up with a sine of x dx, and we'll be able to get rid of the sine of x here that was left over. Now, we will look at another example here because it's very similar whether we choose cosine or sine. So in this case, we can choose cosine to be the function that we convert. So I'll have another example here quickly. It'll be the integral. Let's do sine squared of x cosine to the 5th of x dx. So what we notice here is that our a, our power of sine, is equal to 2, and our b, our power of cosine, is equal to 5. Now, since a is even and b is odd, then we're going to have to choose b in this case to be the one that we're going to convert with the trigonometric identity. So rewriting that identity here in the form that's going to be useful for us, we're going to have cosine squared of x is equal to, well, it's sine squared of x plus cosine of x is equal to 1, so this will equal 1, and then we're going to have to subtract the sine squared of x. So now what we can do is we can take this cosine to the 5th of x, and it's going to be slightly more complicated than the last example. But what we can notice is this is actually a cosine of x to the 4th, or rather cosine to the 4th of x, plus, or rather times, and I'll erase that plus there, times a cosine of x. So it's really an even power times an odd power. Now what we can do is we can say, well, cosine squared of x is equal to 1 minus sine squared. So that means that cosine to the 4th of x is going to have to equal 1 minus sine squared of x, all in parentheses squared, times cosine of x. Now, if we rewrite our integral, we will get sine squared of x times 1 minus sine squared of x, and all of that is squared, times cosine of x dx. Now, rather than choosing cosine as our u here, we're going to want to use the one that's in the parentheses, and that's sine of x. So we have a u equals sine of x, and then our du, well, the derivative of sine of x is cosine of x dx, and we see that here we have our cosine of x dx, and here we have our cosine of x dx, so this looks like it's going to be a very good u substitution. The integral here, we have u squared, and this will be times, in parentheses, we have 1 minus u squared, and this is all squared, and then this will be multiplied by a du. Now what we have to do is we have this integrand here, but we have to distribute it out, so we're able to solve it easily. So we'll have the integral of u squared. Now this will be, and I'll just write it out so it's easiest to understand, 1 minus u squared times 1 minus u squared du. And then if we rewrite that here, we'll have an integral of u squared times, well, that'll be a 1, and it'll be a minus u squared, so we get minus 2u squared. And this will be u squared minus u squared times minus u squared, which will be plus u to the 4th du. And now we just have to distribute this u squared. We get u squared minus 2 u to the 4th plus u to the 6th du. And we started with a rather complicated trigonometric integral, and now we've converted it into a polynomial, which we can use the power rule. So this will be 1/3 u to the 3rd minus 2/5 u to the 5th plus 1/7 u to the 7th plus c. And if we recall that our u here was sine of x, we can plug in a sine of x, and we get 1/3 sine cubed of x minus 2/5 sine to the 5th of x plus 1/7 sine to the 7th of x plus c. And there is our integral. So in the case that, just wrapping up here, whenever we have an integral that is written in the following form, which is a sine to the power of a of x times cosine to the power of b of x dx, and at least one of these, either a and or b is odd, we can always take advantage of the fact that we know that sine squared of x plus cosine squared of x is equal to 1. And we can use a u substitution to be able to get rid of the extra odd power. So in other words, if a is equal to 5 here, well, we know that if a is equal to 5, then we'll have sine to the 5th of x, which will just be equal to sine to the 4th of x times an extra sine of x. And we'll always be able to get rid of that extra sine of x or cosine of x through our u substitution. And notice that this even works in the fact that a or b is equal to 0, right? If I had the integral here of some odd power of sine to the 7th of x dx, and our b was 0, well, we could still do this because this would be equal to the integral of sine to the 6th of x times sine of x dx. And we could then rewrite this as 1 minus cosine squared of x, and this would now be to the 3rd power times sine of x. And we would continue following suit where our u is equal to cosine of x, and then we eventually get rid of this sine of x dx. And the only difference between this is that we wouldn't have an extra cosine, power of cosine, outside of this that we would then plug u in for and multiply. In fact, it would be a much easier example. So that's it. That's the technique for when either a and or b is an odd number. We will discuss the other case where they are both even in the next one. But until then, enjoy the video. Bye.